When any polynomial equation f of x is divided by a linear factor x minus r, the remainder is, that should say equal to, the remainder is equal to f of r, the value of the equation when x equals r. So what that means in English is, if you're just asked for the remainder, all you have to do is take the x-intercept associated with that linear divisor, plug it in for x, and whatever that equals would be the remainder. Alright, so if that does not make sense, hopefully going through a problem will clear it up. The second term on that, where it says 2 cubed, for some reason this happened twice on this one and on number 3. That should be 2x to the 4th. So, going back up to number 1, x plus 2. What x-intercept would that give me? Like, -2. So I'm going to take the equation, and all I'm going to do is plug -2 in for x.
Can you zoom in a little bit?
Yes. Here, let's do this. Will that work?
Yes.
Okay. Alright, so plug all of that whole thing into your calculator. See what it gives you.
Actually, what it is.
So, if that equals -28, I need to put what underneath that? X plus 2. Okay?
Actually, like here.
So, if you were to do long or synthetic division on this problem, the remainder would be -28. Alright, there's two ways that I could see you using this. Alright? One is if the equation just asks, hey, what's the remainder? It doesn't say to divide it, it just says what's the remainder. The other way is if I asked you to do long division, that is a very long process and that whole thing. Okay, to do long division on a problem like this. So if you were to do a problem, let's say on the test, and you got a remainder, and maybe it's a lot bigger number than -28, and you're unsure whether you did it right, instead of going back through that whole problem and double checking every little thing, you could do this and see if this matches up with the remainder that you got when you did long division. So in a way, it's a quick way that you can check your work after you've actually done a problem. Okay, so, and I've had some people in 1A ask me that too. Whenever you're doing the factor or the remainder theorem, you don't have to plug in 0 as a placeholder. You got that, Edwin? You with us? Okay. You do not have to plug it in. So on this one, you're just going to plug in 4 for x and do 4 cubed plus 64. And that would be the remainder. So I want you to go ahead and do the next 3, because it's just that same process. Solve the linear, solve for x on the linear one, plug it in for x in the other one, and that's it.
It's like this.
Alright, this long thing is what you should have put in for the third one. But I raise a hand just because I've had multiple people do this. Raise your hand if you got 6. Alright.
7.
It is 7. Okay, you should have gotten 7 on this. And so it would be 7 over x plus 1. If you didn't, you got negative, you probably, where there was a negative, you put a plus, or where there was a plus, you put a negative. Somewhere in there. Okay? So let's go ahead. For those of you who got to 4, whenever you plugged in negative 4, what did that equal? 0. So there is none. Okay? That would be an example of what is called the factor theorem. Okay? A polynomial. Let me kind of walk through the definition here. A polynomial, x cubed plus 64, has a linear polynomial as a factor only if the remainder is 0. In other words, if the polynomial f of x is divided by a linear factor, x minus r, then f of r equals 0. Okay, so again, in English, what that's saying is if you do the exact same process that we just did for the remainder theorem, and you get 0, that means that that linear factor, x plus 4, that would be a factor of whatever that is, x cubed plus 64. Okay, so the good thing about the remainder in the factor theorem, the process is the exact same. What differentiates them is if you go through that process and you get a number, that's the remainder theorem because that number is your remainder. If you go through the whole thing and you get 0, that's the factor theorem. And what that means is that linear polynomial is a factor of the dividend. Okay, so the good thing is it's the exact same process. You're not learning anything different between the two. It's just you need to know that if it's 0, that means that linear polynomial is a factor. If you get a number, it's not a factor, and that number would be your remainder. All right? So, on that right there, we already said, I already mentioned that x plus 4, yes, that is a factor. Because it came out to 0. And then I want you to do 5 through 7. Now make sure that it's a yes or no question. It's asking, is this a factor of this? So you'll plug it in. If it equals 0, then yes, it is a factor. If you plug it in and it's any number but 0, it is not a factor. Alright, so again, whenever you're doing that, you've got to find you got to solve for x. So that's going to involve subtracting 3 and dividing by 2.
Wait, is that number 6?
Yes, ma'am. So you can either use negative 1.5 or you can use the fraction, which would be negative 3 over 2. Whenever you're doing these, if that fraction, or sorry, if that decimal is not a nice clean decimal like 1.5, use the fraction. Okay, if it was 1/3, you would not want to use 0.33.
So long.
On the last one, you should have gotten, I think it's like 30,000. Is it 282. Okay, so that would not be a factor. All right. Okay, so on this last one's a little different, so make sure that you're paying attention here. Okay. If you're in this section right here, I want you to plug in A and see if it is a factor or not a factor. This row right here, I want you to do B, C, D. This whole section, I want you to do E. Alright, so A. We found that A equals 0, so yes, it is a factor. This row right here, Edrin, what'd you get?
Yes.
2x plus 1 equals 0, so yes, it is a factor.
We got no.
Emma, what did you get? Was it a factor or not? What did you get? Did you do C? Oh, B, you should have gotten 0 on that one too. People who did C, you should have gotten 0. So yes, it would have been a factor. Holly, what'd you get for D? What was the number that you got? 51,714, which is clearly not 0. All right, Kate, what did y'all get? Jen, sorry.
I said yes.
Okay, so those 4 are the ones that are factors on 9. And make sure that you know this. A lot of people see this and they get really confused by the factored form. This up here, what form is this in? Standard form. All factored form is just a list of all the factors. So you would set it up as if I was asking you to multiply all of those together. That's all factored form is. And if I were to ask you to multiply all those together, that is what you would get. Okay?